This lesson covers inverse functions. We've looked at inverses before, so the first question I have for you is, what is an inverse? If you think about it, you probably have some idea already of what that means. One way of describing an inverse, it's a sort of opposite. And remember that inverses always come in pairs. So there's operations that are inverses of one another. For example, addition and subtraction are a pair of inverses, and multiplication and division are a pair of inverse operations as well. Numbers also have opposites. For example, the opposite of 5 is negative 5. The inverse of 5 is negative 5, and the inverse of negative pi is pi. Okay, we're now going to turn our attention to the inverse of a function. Okay, so you have to know what that means. The inverse of a function is what you get when you exchange x and y. So what I'm going to do, I'm going to look at this table right here, and I'm going to take the function f, and I'm going to make a new table that's its inverse. So I take all of these x numbers, 3, 2, 1, 0, and so on, and now I put them in the y column. 3, 2, 1, 0, negative 1, and negative 2. Let me clean that up a little. 3. Okay, and then I'm going to take these y numbers, 9, 4, 1, and so on, and I'm going to put them in the x column. So 9, 4, 1, 0, 1, and 4. So this table represents the inverse of the function f. It's worth noting that this inverse is not a function because if you remember what the definition of a function is, each input or x value can only have one output or y value, and you'll notice that 1 goes to 1, and down here 1 also goes to negative 1. So this is an example of a function whose inverse is not a function. Sometimes the inverse of a function is a function. I'll say more about that later. Okay, so that's a look at inverse functions through the window of a table, looking at the table. Next, we're going to turn our attention to what happens when you graph an inverse. So first, we're going to graph the function f. This is the same function that you saw on the previous screen, and these green dots are just the points that are listed on the chart, 3, 9, 2, 4, and so on. It's probably pretty believable that those ordered pairs come from a larger function whose graph is the parabola that you now see in green. Alright, so now let's consider what happens if we want to graph the inverse. So here's the table of the inverse. And if you plot those points and connect them, you get something that looks like that. And somewhere in here I actually have the points themselves, but they don't seem to want to appear, so hopefully you get the idea there. And one thing that you're supposed to notice, although it's not necessarily obvious from one example or from this example, is that when you look at the graph of a function and the graph of its inverse, they are always going to be reflections across the line y equals x. That's always going to be true. And in fact, that result is important enough that I've written it down right here for you. You might want to pause the video and write that statement in your notes. Okay? And we'll see more examples later. All right. So we looked at tables, we looked at graphs, now we're going to look at equations. Here are 4 steps you can use to find the inverse of a function if you're given its equation. So at this point, just go ahead and pause the video and copy those steps down. And then resume the video and I'll show you how to do those 4 steps. Okay? All right. So here's an example. And in fact, this is the very function that we were graphing on the previous screen. So I'm now going to do step number 1. I'm going to replace f of x with y. So now I have y equals x squared. And then the second step is to exchange x and y. So instead of y, it's x, and instead of x, it's y. And then I need to solve for the new y. So in order to do that, I'm going to have to take the square root of y squared. Whenever you take the square root of both sides of an equation, you need to remember to introduce the plus or minus sign. And then the square root of y squared, I'm going to come up here, is y. And oops, I forgot to take the square root of this side. Sorry about that. So the square root of y squared is plus or minus square root of x. So y equals plus or minus root x. And it's nice to put the y in the front. So y is plus or minus square root of x. And the final step is to rewrite that with an f inverse. That's like this. That just means the inverse function. You do that if the result is a function, but in this case it's not because of that plus or minus. You plug in a certain x value, you get out two y values, a positive one and a negative one. So that example is not really, the inverse is not a function, so you would just stop here and you would describe the inverse with that equation, or actually two equations, square root of x and negative square root of x. Okay, let's look at another example. Okay, so step 1, replace f of x with y. Step 2, exchange the y's and x's. And then solve for y. I'm going to add 5 to both sides. Then I'm going to divide both sides by 3. And I'm done. Now this one, the inverse is a function, so the best way to write my final answer would be like this. And we read that f inverse of x is x plus 5 over 3. Okay, so there's your homework. Pause the video if you need to copy them down. And number 1, A, B, and C, it's what I just demonstrated. Number 2 is a thinking question. And number 3 actually requires you to review something we did in the previous term. Okay, have it ready for class next time. Thanks.